Welcome! I am absolutely thrilled to have you here for this explainer, because today we are unpacking the definitive guide to the ultimate tool for freshwater independence at sea. Look, if you spend any significant amount of time on the ocean, you already know that water management isn't just some minor convenience, it literally dictates your entire journey. So today we're demystifying the marine watermaker. We're going to break down exactly how it works, what goes wrong, and most importantly, how to master it.
Water, water everywhere, nor any drop to drink. We've all heard that classic line from the Rime of the Ancient Mariner, right? And it perfectly captures the ultimate irony of seafaring. I mean, you are completely surrounded by water, yet running out of fresh drinking water is one of the highest stakes scenarios a crew can possibly face. Historically, sailors were entirely at the mercy of their limited tank capacities and, well, whatever rain they could manage to catch. But modern engineering has completely flipped that script.
Okay, let's dive into this. Here is our roadmap. 1. Freshwater independence at sea. 2. The reverse osmosis process. 3. Common watermaker pitfalls. 4. Essential maintenance and fixes. And 5. Automated solutions and tech.
Section 1. Freshwater independence at sea. Now, a watermaker is often thought of as this fancy luxury add-on. But for long-distance cruisers and super yachts, it's actually a foundational, absolutely critical system. Why? Because the ability to produce potable water anywhere means you save time hunting down marinas, you save physical space on board by requiring smaller water tanks, and you save fuel because your vessel is traveling significantly lighter. So what exactly is it? Essentially, it's a mechanical reverse osmosis system that utilizes high-pressure pumps to push salt water through a semi-permeable membrane, producing safe, fresh drinking water. This incredible piece of tech effectively transforms the entire ocean into your own infinite freshwater tank.
Section 2. The reverse osmosis process.
To really understand how this works, we need to follow the fascinating mechanical gauntlet that a single drop of seawater has to run through just to become drinkable. Step 1 starts right at the hull, where a low-pressure pump pulls seawater through a 50-micron sea strainer just to catch the big stuff. Step 2 pushes that water through increasingly fine pre-filters, first 20 or 30 microns, then down to 5 microns, and often an oil separation filter. Then we hit Step 3, the high-pressure pump. Finally, Step 4 is the semi-permeable membrane. I actually love to use the heart and kidneys analogy for this. The high-pressure pump in Step 3, that's the beating heart, forcefully driving the system. Meanwhile, the microscopic pores of the membrane in Step 4 act as the kidneys, meticulously filtering out the salt and impurities.
Now, you might naturally assume that most of the water pumped in becomes drinking water, but the reality is actually a massive 90-to-10 ratio. That's right, only about 10% of the supply water manages to squeeze through those microscopic membrane pores to become fresh product water. The remaining 90%? That's used to continuously flush away the heavy salt and solids, discharging them right back overboard as brine. So it requires a massive amount of flow just to get a little bit of fresh water.
Section 3. Common watermaker pitfalls.
Because of all that intense continuous flow and precision filtering we just talked about, these machines can be, well, a bit finicky. In fact, that mechanical kidney can act like a demanding diva on a yacht if you don't treat it right. They have very specific loves and absolute hatreds. You absolutely do want to keep the membrane wet, use the system regularly, even daily if you can, and always flush it with unchlorinated product water. Conversely, you don't ever want to operate in silty, oily harbors. Never let the membrane dry out, and, this is huge, absolutely never use chlorinated tap water. Watermakers absolutely hate inactivity, and a single blast of chlorine from a dockside hose will instantly and irreversibly ruin a semi-permeable membrane.
When things do go south, it's usually one of a few usual suspects. Clogged pre-filters are incredibly common, and that drops your supply pressure. Then you have biological growth from stagnant water, which is basically marine life blooming inside your pipes. Gross, I know. As water evaporates, salt crystallizes, which then clogs those tiny internal passages. You'll also see dried-out cracked O-rings, and if left in the cold, freezing damage to pumps. Are you noticing a theme here? Almost all of these mechanical enemies stem from either ignoring the system while it's active or failing to properly prepare it for long-term storage.
Section 4. Essential maintenance and fixes.
Okay, it is time to equip you with the step-by-step playbook to prevent all those failures we just listed. To ensure your membrane survives its full 5+ year lifespan, you need a solid routine for off-season storage, which is known in the industry as winterization or pickling. Step 1 is a thorough 30-minute flush with unchlorinated fresh water just to purge all the salt. Step 2 is the actual pickling. This means circulating a specialized biocide solution throughout the system. This solution sits in the pipes and the membrane, completely preventing that biological growth we talked about while the system sits idle for months. Step 3 is inspecting and lubricating your seals so they don't dry out. And step 4 is powering down and disconnecting electronics to protect them from moisture and cold. Do this whole routine and your system will wake up perfectly in the spring, ready to go.
Section 5. Automated Solutions and Tech.
But hey, what if you could take a lot of that manual labor and human error completely out of the equation? Well, modern marine engineering is stepping in to solve the exact pain points we've been discussing, and honestly, the advancements are truly remarkable. Historically, about 80% of Watermakers sold required manual operation. That meant an owner or a crew member had to physically climb down into a hot, incredibly noisy engine room, manually open supply valves, adjust high-pressure regulators, wait around for the tank to fill, and then go all the way back down to manually initiate a freshwater flush. It was a tedious chore that, let's be real, easily led to skipped maintenance. But modern hardware, like the HPSCA unit, is changing the game by integrating fully automated pressure regulation and flushing cycles right into highly compact footprints. And this brilliantly illustrates the ultimate modern fix. By integrating the Watermaker's brain with the vessel's existing network, systems like the HP PartNet interface pull the entire operation out of the engine room and put it directly onto the ship's navigation plotters. We're talking major brands like Garmin, Raymarine, and Furuno. A captain can now monitor water quality, start the high-pressure pump, check the maintenance logs, and even run automatic pickling sequences right from their touchscreen helm. They can literally make fresh water without ever taking their eyes off the nautical chart. It's a real game changer.
Which leaves us with this final really fascinating thought. As automated integration brings these complex, historically forgotten systems right to our fingertips, what other engine room machines are going to become smart next? The evolution of marine technology is moving incredibly fast, and it is completely transforming the way we live and travel on the ocean. Thank you so much for joining me to explore the fascinating world of marine water makers on this explainer. Keep learning, stay curious, and I will see you next time.